Welcome to The Explainer. Today, we are unpacking a really fascinating piece of private, exploratory AI research from June 2026. It's called the AI Lens Experiment. Now, the researchers essentially asked a brilliant question. What happens if we try to teach an artificial intelligence to read between the lines of a human conversation? Instead of just throwing a standard prompt at an AI to summarize a transcript, what if we injected scientifically established analytic frameworks, stuff from cultural and social sciences, directly into the AI's environment? Would treating the AI like a sociologist actually make it a smarter, more nuanced reader of human interaction? Well, we've got the data, so let's find out. Here's our quick agenda for today. We are going to hit the initial AI lens hypothesis, walk through their automated testing methodology, look at the 4 prompting approaches they used, reveal what the tests totally disproved, and finally, look at what actually held up under scrutiny. All right, let's jump right into Section 1, the AI lens hypothesis. Can theory actually make an AI smarter? So if you look at modern contact centers, AI analysis is often this opaque black box. It spits out a score, but the actual reasoning is completely hidden from you. To solve this surface-level reading, the researchers hypothesized using something they called a declarative frame schema, or DFS. Think of this as a method-declared approach to AI prompting. Basically, it means wrapping your prompt in established social science theory, like conversation analysis or pragmatics. The big idea here was that by explicitly declaring the ontology, the observer position, and the analytical objects right there in the prompt, this DFS approach would yield way more accurate and nuanced extractions of hidden phenomena. Teach it to think like a social scientist, and theoretically, it should catch all the subtle things standard AI completely misses. Moving on to Section 2, the automated testing methodology. Now, the researchers didn't just guess here. They wanted highly reliable empirical data. So they built a rigorous, automated pipeline. First, they injected blind contact center transcripts into the system. We're talking scenarios like a customer dealing with a malfunctioning healthcare bot, or maybe a tech support agent who is perfectly competent but completely cold. Then they ran automated tests using tools like OpenRouter and PromptFu across top-tier models, specifically Claude's Sonnet 4.6 and Gemini 2.5 Pro. Finally, to evaluate the outputs, they used a multi-judge LLM ensemble to objectively score the results against a hidden ground truth key. By automating the whole shebang, they completely stripped out human bias. Section 3. Comparing the 4 prompting approaches. To really test this, they set up an escalation of complexity across 4 distinct variables. They started at the bottom with bare NL, just your standard unstructured natural language prompt, like, hey, rate this agent's empathy. Next step up was directed NL, which asked structured, specific questions but didn't use any social science theory. Third was their prized brainchild, DFS, which took that structured prompt and wrapped it into declared social science methodology. And finally, they cranked the dial all the way up to an all frameworks condition. This was a heavy academic theory overload, literally forcing the AI to apply 5 different frameworks at once, including stuff like hermeneutics and critical theory. All right, Section 4, this is the Mythbuster reveal. Let's talk about what was completely disproved. So, the million-dollar question. Did teaching the AI all these social science frameworks actually make it a better, more nuanced reader of human interaction? Did it magically catch those subtle, hidden failures that the simpler prompts entirely missed? Well, the data gives us a massive, definitive no. The expectation going in was that DFS would easily beat the simpler directed NL approach when it came to recalling nuanced info. But the reality? Across all evaluated scenarios, the DFS approach recovered the exact same keystone phenomena as the simpler structured prompt. Literally never more. The data proved that an AI's ability to spot a failure relies heavily on the transcript having legible surface markers. If there's an explicit contradiction in the text, all the models catch it. But if it's highly interpretive, say that healthcare bot where the agent's extreme warmth is actually the failure, almost all conditions completely miss it, no matter how much method you pack into the prompt. Theory absolutely did not boost accuracy here. Actually, it gets wilder. Giving the AI too much theory was genuinely dangerous. The all frameworks approach caused the AI to completely hallucinate. Imagine a call with a very genuine, polite customer service apology. Well, the AI, acting a lot like an overzealous sociology grad student, labeled that perfectly normal interaction as functioning hegemony and ideological absorption. Burdened by all that critical theory and systems theory, it wildly overread the situation, imposing a heavy frame that totally contradicted the actual ground truth reality of what was happening on the call. But wait, let's look at Section 5. What actually held up here? Because there is a true value. While the whole extraction accuracy hypothesis totally failed, the experiment itself wasn't a loss. The scientifically validated value of the DFS approach turned out to be something else entirely: auditability. So, auditability is the ability of an AI to emit checkable boundaries, logged assumptions, and rejectable hedges. That DFS declaration layer we talked about, it successfully forced the AI to stay incredibly disciplined in how it reported its findings. And for a business, that is a massive structural advantage for AI governance, compliance, and quality assurance.
Just look at this discipline in action. A standard, bare prompt might make a wild, unhedged assertion like, "This is a compliance failure," which, of course, creates absolute chaos with false regulatory alerts. But the DFS method, it forces explicitly hedged intent. So it outputs something like, "This reads as scam-shaped, but the intent is unconfirmed." Do you see the difference? It names the pattern perfectly, but explicitly brackets the intent. It structurally knows its own boundaries as an observer, which is exactly what you want.
Finally, Section 6. Let's look at the weighted answer and our final takeaway.
This beautifully illustrates the split in the June 2026 data. On the left, the extraction hypothesis failed. DFS does not increase accuracy, and it absolutely does not beat a well-directed natural language prompt because recall is always going to depend on structural surface markers in the text. But on the right, the governance hypothesis was a massive success. You don't use the DFS approach to get a magical accuracy uplift. You apply it because it creates those checkable boundaries and forces explicitly hedged auditable outputs. That is what actually keeps a business safe from rogue AI hallucinations.
I want to leave you with this final provocative thought. In this industry, we are constantly trying to make AI smarter by feeding it deeper human theories and more complex prompts. But if this rigorous empirical data proves that deeper theory does not equal higher accuracy, where else in our workflows are we currently measuring LLMs with the completely wrong yardstick? It's a fascinating puzzle, and one that really should change how we build and evaluate our AI prompts from here on out.